Subtraction of fractions is very similar to addition of fractions. We express each of the fractions over the same denominator using the L.C.M. Then we do the subtraction. Then the denominator of the answer remains as the denominator that we use when we are doing the subtraction. So the first example, let's subtract two fractions, 5 over 7 minus 2 sevenths. In this case, both denominators are the same, and the LCM of the same number is that number itself. So the LCM of 7 and 7 is equal to 7. Draw this line and put the LCM below. We know the LCM is 7. And 5 over 7 is the same as 5 over 7. And 2 over 7 is the same as 2 over 7. 5 take away 2 is equal to 3. And we use the same denominator. 5 sevenths minus 2 sevenths is equal to 3 over 7. Second example, 1/2 minus 1/3. The LCM of 2 and 3. 2 into 2, 1. 2 into 3 cannot go into it exactly. So we write back the 3. 2 cannot go into 3 or 1. So we use the next prime number, which is 3. 3 into 1 cannot go into it exactly. 3 into 3, 1. So we finish. 2 multiplied by 3 is the LCM. The LCM is equal to 6. So both fractions are going to be expressed over 6. 2 multiplied by what will give you 6? 2 multiplied by 3. So you multiply 3 by 1. Take away. 3 multiplied by what will give you 6? 3 multiplied by 2 will give you 6. So you multiply 2 by 1. Now we subtract. 3 take away 2 is equal to 1. And we keep the denominator. So 1/2 minus 1/3 is equal to 1/6. Simplify the following. 3 and 1/4 minus 2 and 3/8. Taking away the whole numbers, 3 take away 2 is equal to 1. The LCM of the fractions, 4 and 8. The LCM of 4 and 8 is equal to 8. You could try it on your own to confirm. 4 multiplied by what will give you 8? 4 multiplied by 2 will give you 8. So we multiply 2 by 1 to get 2. So 2 over 8 is the equivalent fraction of 1 over 4. Take away. 3 over 8 is the same as 3 over 8. So here we have 1 and 2 take away 3 over 8. 2 cannot take away 3 to give a positive number, so we will borrow 1 whole. We borrow 1 whole from here to add it to the 2. If we borrow 1 from 1, we'll be left with 0. And a whole, remember a whole is equal to any number over itself. So we want to put it over 8, then it means that it will be 8 over 8. So we take that 8 that we borrowed and we add it to the 2. We are left with 10. So we have 10 take away 3. 10 take away 3 is equal to 7. We have 0 whole number and 7 over 8, or just 7 over 8. Example 4, 3 take away 5 sevenths. 3 take away 0 whole number is equal to 3. And we have no whole number here. In essence, it's 0. We have 0 over 7. Take away 5 over 7. When we have 7 and nothing else, then we use 7 as the LCM. 0 cannot take away 5 to leave a positive whole number, so we borrow 1 from the 3. We borrow 1 from 3, left with 2. Now this 1 whole is going to be represented as a fraction over 7. And we know that 7 over 7, or any number over itself, is equal to 1. This 1 whole, so we add 7. 7 plus 0 is equal to 7. 7 take away 5 is equal to 2. So we get 2 and 2 sevenths. So in this case, we have 1 and 5 sixteenths. Take away 4 over 5. 1 take away 0 is equal to 1. What's the LCM of 16 and 5? 2 into 16, 8. 2 cannot go into 5 exactly. So we write back to the 5. 2 into 8, 4. 2 cannot go into 5 exactly. 2 into 4, 2. 2 cannot go into 5 exactly. 2 into 2, 1. Neither 2 nor 3 can go into 5. 5 into 5 is 1. 5 into 1 cannot go into it exactly. 2 multiplied by 2 is equal to 4. 4 by 2 is 8. 8 by 2 is 16. 16 by 5 is 80. The LCM of 16 and 5 is equal to 80. 16 multiplied by 5 is equal to 80. So we multiply 5 by 5 to get 25. Take away 5 multiplied by 16 is 80. So we multiply 16 by 4 to get 64. So 4 over 5 is the same as 64 over 80. 25 cannot take away 64 to leave a positive number, so we borrow 1 from the whole number to be left with 0. And as before, we know that any number over itself is equal to 1, so this 1 will be 80 over 80. So we add 80 to the 25. 80 plus 25 is that 105 minus 64 will give you 41. We have 0 and 41 over 80.